We will continue the course for EPA 608 Universal Certificate. Okay, we will continue this course for refrigerants. Let's start.
In this module, we will define refrigerant and also discuss different types of refrigerants.
Have you ever wondered how your refrigerator keeps your favorite ice cream cold? In the refrigeration cycle module, we discussed how refrigerant absorbs heat from hot indoor air and transfers it outdoors. This is how air conditioning units provide cooling. This is also how your fridge keeps your favorite ice cream cold. Your refrigerator makes use of the refrigeration cycle to transfer heat from the inside of your fridge to the outside. The key to making this happen is the refrigerant. A refrigerant is a working fluid in refrigeration cycles that absorbs and loses heat quickly, changing phases from liquid to vapor in the process. We can choose from any number of substances to use as a refrigerant. Good refrigerants are cheap and have a low boiling point. Low boiling points are necessary because we need the refrigerant to boil at room temperature. Remember, the boiling of refrigerant is what provides the cooling effect. However, as we discussed in the ozone layer module, some refrigerants are harmful to the environment. Some refrigerants are also more flammable or toxic than others. That is why it is important to look at the properties of different refrigerants. We need to consider their effect on the environment as well as how safe they are. CFCs were widely used in the mid-1900s before it was discovered that they were depleting the ozone layer. As we discussed in key regulations, these refrigerants were the first to be phased out. We say pure refrigerants to distinguish from refrigerant blends, which consist of multiple refrigerant substances. Pure refrigerants consist of one substance only. We will discuss refrigerant blends in a later module. There are 5 major categories of pure refrigerants that we will cover for the EPA exam. CFCs, HCFCs, HFCs, HFOs, and natural refrigerants. CFCs and HFCs are categories of refrigerants. This means there are multiple refrigerants that are CFCs or HFCs. Think of categories of refrigerants as shades of the same color. For example, something that is blue could be sky blue or ultramarine or indigo. To reiterate, CFCs are a category of refrigerants, not one specific refrigerant. A CFC refrigerant, for instance, could be any number of specific refrigerants, including R11 and R12 refrigerant. In this module, we define refrigerants and their types. In the next module, we will delve further into CFCs and HFCs.
This is the introduction. Okay, so we'll see in this module CFCs and HCFCs.
In this module, we will discuss the first 2 types of refrigerants, CFCs and HCFCs.
There are 5 major categories of pure refrigerants that we will cover for the EPA exam. CFCs, HCFCs, HFCs, HFOs, and natural refrigerants. In this module, we will discuss the first 2, CFCs and HCFCs. CFCs are a category of refrigerants called chlorofluorocarbons. R11 and R12 are examples of CFC refrigerants. CFCs are made of chlorine, fluorine, and a carbon.
What does CFC stand for? Chlorocarbon, fluorocarbon. Okay, I think this one chlorofluorocarbon. Let's submit and see. Yes, it's correct. Okay, CFC contain which of the following? Select that apply. CFC it's contain carbon and fluoride and chlorine. Yeah, correct. Which of the following are CFC? Choose that to apply R12 and R11.
HCFCs are made of hydrogen, chlorine, fluorine, and a carbon.
What does HCFC stand for? It is hydrochlorofluorocarbon.
HCFCs are a category of refrigerants called hydrochlorofluorocarbons. R22, R123, and R124 are examples of HCFC refrigerants.
Other than fluoride and chlorine. Okay, what do HCFC contain? It's fluorine and chlorine. It's hydrogen and the carbon. HCFC contain which of the following? Okay, fluorine, chlorine. Okay, yeah, no, these two. Which of the following are HCFC? R123, R124. Sorry, 100, R22, 123. R22 and R123, also R124. Yeah.
HCFCs were developed as a transitional alternative to CFCs. Although not as harmful as CFCs, HCFCs still have chlorine, so they still destroy ozone in the atmosphere. HCFCs have mostly been phased out in developed countries. This means that it is illegal to produce or import HCFCs. Nevertheless, HCFCs are still used in existing refrigeration equipment. The most common of HCFCs we still see today is R22.
Which of the following is HCFC that's still servicing refrigerant system today? It's R22.
In this module, we discuss the historic use of different refrigerants including those harmful to the ozone layer, CFCs and HCFCs. We also looked at the refrigerants that do not contain chlorine, and therefore, do not harm the ozone layer. In the next module, we will discuss the characteristics of these refrigerants in further detail.
Okay, we will continue here. HFCs, HFO, and natural refrigerant.
In this module, we will delve further into different types of non-ozone depleting refrigerants.
HFCs were developed as an alternative to CFCs and HCFCs. They were effective as refrigerants and did not contain chlorine, so they did not destroy the ozone layer. But it turned out that while HFCs do not deplete the ozone layer, they contribute to global warming. We will go into specifics of global warming later in this module. HFCs are a category of refrigerants called hydrofluorocarbons. R32, difluoromethane, R125, pentafluoroethane, and R134A, tetrafluoroethane, are all examples of HFC refrigerants. HFCs are made of hydrogen, fluorine, and carbon.
Which of the following are HFCs? These are 130A and I think no, also R32. Yeah.
As we discussed in key regulations, CFCs have been phased out, and HCFCs will soon be phased out. HFCs are also in the process of being phased out because of their high global warming potential. Then there's HFOs, which are a new class of refrigerants. HFOs have much lower global warming potential than HFCs. HFOs are a category of refrigerants called hydrofluorolefins. The HFO refrigerant we see most commonly is our 1234YF tetrafluoropropane. HFOs are composed of hydrogen, fluorine, and carbon. Notice that the elements that HFOs are made of do not directly correspond to the letters in its name, as it has been the case with other refrigerants. Notice also that HFOs have the same elements as HFCs. HFOs are not compatible with silicone. In the presence of HFOs, silicone elastomers used in seals and gaskets in refrigeration systems swell, which affects how the system behaves.
What does HFO stand for? It is hydrofluorocarbon. Hydrofluorooxygen. Hydrofluoroolefins. Which of the following HFO contain? It's fluoride and hydrogen and carbon. Fluoride and carbon, not the same as the name. Which of the following HFO? I think this one. Yeah, R1, 2, 3, 4, YF.
Notice that HFOs do not contain chlorine, so they do not destroy ozone. Compared to HFCs, they contribute very little to global warming. Different types of refrigerants were developed in order to provide an alternative to ozone-depleting and global warming refrigerants. These alternatives are called natural refrigerants. They are called natural refrigerants because they can be found in nature and are generally more environmentally friendly than other refrigerants. Examples of natural refrigerants include HCs, or hydrocarbons, carbon dioxide, and ammonia. Examples of hydrocarbons are propane, which is known as either R290 or HC290, and isobutane, which is known as either R600A or HC600A. Note that propane is commonly used for grilling. Because it is highly flammable, it is great for starting a fire. However, the propane used for grilling cannot be used to charge refrigeration systems. The propane cylinders used for grilling are not rated for refrigerant use. This is because they contain impurities that can damage refrigeration equipment. Propane used for refrigeration purposes is labeled R290. Carbon dioxide can also be used as a refrigerant. As a refrigerant, it is known as R744. Ammonia as a refrigerant is known as R717. It has been used since the 1850s for various cooling purposes. We see ammonia today mostly in commercial applications.
Which of the following are natural refrigerants? R600, yeah, and HC600A, I think, yeah. Which of the following is natural refrigerant? R717 and 700. I think all. No, R100 to 90. 130 not. Yeah. R400 is the same of. R410 is the same as. I don't know this answer. HCH of O410. I don't know. Yeah, is an HFC. So the same like HFC 410A.
In this module, we discussed the non-ozone depleting refrigerants that were developed as an alternative to ozone depleting refrigerants like CFCs and HCFCs.
Okay. Okay, let's go to refrigerant naming.
In this module, we will discuss different naming conventions for the refrigerants.
To wrap up this discussion on different types of refrigerants, let's go over some alternative naming conventions for the refrigerants we just looked at. Refrigerants may be named by a combination of R and a number, where the letter R refers to the fact that this chemical is a refrigerant. This naming convention was developed by ASHRAE, so this number can also be called a refrigerant's ASHRAE number. ASHRAE is a global organization of engineers that establishes guidelines and standards in the HVAC industry. For example, R12 is the name of a refrigerant using its ASHRAE number. As we discussed in the previous module, R12 is a CFC. R12 is the same as CFC12. These are two common ways of referring to the same refrigerant. As long as the numerical value is the same, it is the same refrigerant. To avoid confusion, there is no HCFC12 or HFC12. R12 is used only to refer to CFC12. To reiterate, the following refrigerants are the same. R12 is the same as CFC12, R22 is the same as HCFC22, R134A is the same as HFC134A, and R1234YF is the same as HFO1234YF.
R134 is the same as HC. Okay. I don't remember this one. I think HFC. Yeah, HFC. R1234YF is HCFC 123. Okay, so HFO. Yeah. R11 is same like HFC 11. HFO. No. R12 is the same like CFC 12. R410A is same like HSVC, same like HFC 400A.
In this module, we identified the different trade names and naming conventions for each type of refrigerant. For example, CFC11 and R11 are trade names for the same CFC refrigerant.
Ozone depletion potential.
In this module, we will define ozone depletion potential and how it is used to determine the harmfulness of different refrigerants.
In our ozone module, we learned that ozone is a molecule in the atmosphere that absorbs harmful UV rays from the sun, preventing them from reaching the Earth's surface. When released into the atmosphere, certain refrigerants are especially potent at destroying ozone. This is because the refrigerants contain chlorine. CFCs and HCFCs are the most harmful because they contain chlorine and are relatively stable, meaning they don't get destroyed easily by rain or sunlight. This makes it more likely that they will reach the stratosphere, where the ozone layer is. Refrigerant chemicals have a lifespan of 70 to 100 years. This is how long they can stay in the atmosphere, destroying ozone until they are broken down naturally. We can characterize the potential of a refrigerant to destroy ozone as its ozone depletion potential, ODP. The ODP number we assign to a refrigerant tells us how harmful that refrigerant is to ozone in the atmosphere. CFCs are the most destructive to the ozone layer, so their ODP is the highest. The next most destructive are HCFCs. You can think of ODP as similar to the Richter scale, which describes the severity of earthquakes. On the Richter scale, the higher the number is, the larger the magnitude of the earthquake. In terms of ODP, the higher that number is, the more harmful the refrigerant is for the ozone layer.
The lowest number for an ozone depletion potential, ODP, is 1. Yeah. Incorrect? False. Okay. The highest is 1.
ODP is a
Yeah.
scale that determines how much ozone-depleting potential substances have when compared to each other. Of all modern refrigerants, starting with CFCs, the highest ODP is 1. R11 and R12, which are both CFCs, both have an ODP of 1. All the HCFC, HFC, and newer refrigerants have an ODP of less than 1. This is because they are less harmful to the ozone layer than R11 and R12. Note that there are older refrigerants that have an ODP of greater than 1. This means that they are more harmful to the ozone layer than R11 and R12. This includes halogens, which were once used in fire extinguishers but have long since been banned.
Which type of refrigerant is the most harmful to the ozone layer? CFCs.
Let's look at the ODPs of several commonly used pure refrigerants. This chart shows the ozone depleting potentials of different examples of each type of refrigerants. Notice that R11 has the highest ODP of 1. R11 is the most destructive refrigerant, and we compare all other refrigerants against it. Note also that R11 is a CFC, which, as we have already discussed, is the most destructive type of refrigerant. R22, which is an HCFC, has an ozone depletion potential of 0.05. This means that it still depletes the ozone layer, but at a much lower rate than any CFC refrigerant. R410A, which is an HFC refrigerant, and R1234YF, which is an HFO refrigerant, both have an ozone depletion potential of 0. As we discussed earlier, neither HFCs nor HFOs contain chlorine, so they do not break down ozone molecules. This is why their ODP is 0. Natural refrigerants like nitrogen, carbon dioxide, water, and hydrocarbons, HCs, such as propane, R290, and isobutane, R600A, also have an ODP of 0 since they do not contain any chlorine.
Which type of refrigerants at least harmful to the ozone layer? HFO, no, no, HFC, no, they are non-ozone depleting. HFC and HF, oh, both. What is the highest possibility? 1. What is the least possibility for refrigerant? 0. What is the ODB for R600A? I don't remember this one, but I think this. No? This one? 0.25? No. 0. Which of the following refrigerant have ODB greater than 0? Greater than 0, yes. R12 greater than 0 for sure. And R22. Yeah. What is the ODB for R44? I don't remember. I think 0.10. Yeah. If a refrigerant has ODB of 0.05, which of the following is true? It contains chlorine. It might contain chlorine. It could be. Yeah. Incorrect. Okay. It contains chloride. Incorrect. If a refrigerant has ODB, if anything, greater than. Okay, it must contain chloride. Okay. That is responsible for destroying the ozone. It has ODB. It could be R20T. Yeah.
In this module, we defined ozone depletion potential, ODP. We also compared the ozone depletion potential of different refrigerants.
Yeah. Global warming potential.
In this module, we will discuss the other harmful properties of different refrigerants.
Aside from the potential to deplete the ozone layer, certain refrigerants also contribute to global warming. Let's take a look at a short video to review the basics of global warming.
Is the greenhouse effect? Earth is a comfortable place for living things. It's just the right temperature for plants and animals, including humans, to thrive. Why is Earth so special? Well, one reason is the greenhouse effect. A greenhouse is a building with glass walls and a glass roof. The clear glass allows sunlight to shine into the greenhouse while also trapping the sun's heat inside. This is how a greenhouse keeps plants warm even at night and in the winter. The greenhouse effect keeps Earth warm in pretty much the same way. Earth isn't surrounded by glass, but it is surrounded by a jacket of gases called the atmosphere. In the daytime, the sun shines through the atmosphere, warming Earth's surface. After the sun goes down, Earth's surface cools. This releases heat back into the air, but some of that heat is trapped by the gases in the atmosphere. These heat-trapping gases are called greenhouse gases. Carbon dioxide, water vapor, and methane are all examples of greenhouse gases. Earth needs a balance of greenhouse gases to maintain just the right temperature for living things. But some human activities are changing Earth's natural greenhouse effect. For example, burning fossil fuels like coal and oil releases more carbon dioxide into our atmosphere. These extra greenhouse gases can cause the atmosphere to trap more and more heat, leading to a warmer Earth. NASA satellites are constantly measuring the gases in our atmosphere from space. They've observed increases in the amounts of carbon dioxide and other greenhouse gases. The information from NASA satellites can help scientists figure out where greenhouse gases are coming from, and how they are ending up in our atmosphere. This information will help us better understand the impact that greenhouse gases have on our climate.
The term climate change is a bit different. It's more about the effects of this global warming on the climate. And remember, climate just describes long-term weather patterns. For example, one of the consequences of global warming is that rare weather events like droughts, hurricanes, and floods will become both more common and more severe. So we refer to these changes under the term climate change. Another consequence of global warming is sea level rise, which actually happens for two different reasons. One is that the higher temperatures will cause more ice to melt, which will then flow into the ocean. The second is that as the water in the oceans warms up, it expands, and so its volume will increase, making the sea levels rise even more. And this rise in sea levels will lead to seasonal flooding across the world, and in some places, the submersion of entire islands and coastal towns. Climate change will also have a more general impact on the wild organisms across the world. As temperatures and rainfall patterns change, species that were perfectly adapted to their environment might not be able to survive anymore. In some cases, species might be able to adapt to the new conditions, or maybe migrate to other regions where the conditions are a bit better. And we are seeing these things happen in some places already. For example, lots of species are slowly moving towards the poles where it's cooler. Unfortunately though, lots of species can't adapt or migrate fast enough. And biodiversity is likely to fall dramatically in the next few decades.
As discussed in the two videos, gases like carbon dioxide naturally trap heat in the atmosphere, making the Earth warm enough to be habitable. We refer to these gases as greenhouse gases. An increase in greenhouse gases like carbon dioxide traps more and more heat from the sun. This leads to disruptions in the climates of Earth, leading to extreme weather events. Some gases are more potent at trapping heat than others. We measure how much X to global warming potential, GWP. This number is different for each gas. GWP measures how much energy 1 ton of gas will absorb over 100 years compared to carbon dioxide. By definition, carbon dioxide has a GWP of 1 because it is the gas we use as a reference to compare other gases to. If the GWP of a substance is greater than 1, then it has a higher global warming potential than CO2. The higher the GWP, the more heat the gas traps in the atmosphere. For example, if a gas has a GWP of 2, it means it will absorb 2 times as much energy as carbon dioxide over 100 years. If it has a GWP of 500, it will absorb 500 times as much energy as carbon dioxide over 100 years. GWP is a number that quantifies the effect of a chemical on the environment. It allows policymakers to compare and make decisions on what regulations are needed.
Which gas is used as a reference for measuring GWP? Carbon dioxide? Yeah. GWP is measuring of how much energy gas trapped in the atmosphere over 100 years. Yeah. Which of the following statement about carbon dioxide is true? Carbon dioxide has a GWP of 1. Carbon dioxide has a GWP of 0, I think. Has an ODP of 0. I don't know. Incorrect. 0 also. Incorrect. Carbon dioxide has GWP of 1 and DP of 0. If a gas has a GW of 50, this means it has 50 times less low global warming potential than carbon
Let's
dioxide.
take a look at the
Greater,
global warming
not less.
potentials of a few refrigerants. This table shows 5 different refrigerants. It includes their trade names and global warming potentials, GWPs. Notice that R12, a CFC refrigerant, has the highest GWP. It has a GWP of 10,900, meaning it has a global warming potential that is almost 11,000 times higher than that of carbon dioxide. We see here that our 410A, an HFC refrigerant, has a higher GWP than our 22, an HCFC refrigerant. This is noteworthy because HFCs were produced as an ozone-friendly alternative to HCFCs. While HFCs do not deplete ozone, they do contribute to more global warming than HCFCs. This is why these refrigerants are also being phased out, as we discussed in key regulations. Compared to all of the other refrigerants on this list, we see that the refrigerants with the least global warming potentials are our 1234YF, which is an HFO refrigerant, and our 600A, which is an HC, hydrocarbon, refrigerant. This chart illustrates how each type of refrigerant corresponds to its global warming potential. In general, CFCs have the highest global warming potential. We can see that our 12 refrigerant has a much higher GWP than the others. HFOs and HCs have the lowest global warming potential. Remember, these refrigerants were developed after CFCs, HCFCs, and HFCs to provide an alternative to the high global warming potential of the older refrigerants.
Which one of the following refrigerants has the highest global warming potential? Yeah, it's R12. Okay. Which one of the following refrigerants has the lowest global refrigerant? I think this one. Yeah. R12 has a GWP in which the following range from 10 to 50,000. R410 has a GWP which of the following range? I don't remember. 1 to 500. This means it has 20. The range from 1000 to 10. This one. Which type of refrigerant have the lowest GB? Two types. Which two types? Lower GB. Okay. HFO and HCS. Yeah. The DWB and HFO and HCs are close to the H of HCFCs. False. The DWB of R290 is greater than which of the following? Of R134. No? Of
In this module, we discuss the
R410.
characteristics of different
No?
types of refrigerants.
R22.
Certain refrigerants deplete the ozone, others have high global warming potential. We also have to consider the different classes of safety of individual refrigerants in order to take proper safety precautions.
Okay. We will take ASHRAE safety classification after this quiz.
In this module, we will discuss how refrigerants are classified based on their flammability and toxicity.
ASHRAE is a global organization of engineers that establishes guidelines and standards in the HVAC industry. ASHRAE stands for American Society of Heating, Refrigeration, and Air Conditioning Engineers. ASHRAE came up with the refrigerant safety classification system based on the flammability and toxicity of a refrigerant. This system is called Standard 34. This is the system that is used as a standard to understand the safety of different refrigerants. Refrigerants are classified according to flammability and assigned Class 1, 2, or 3. Class 1, non-flammable refrigerants, Class 2, low flammability refrigerants, and Class 3, high flammability refrigerants. Refrigerants are also separated into two classes according to their toxicity. Class A, low toxicity refrigerants, and Class B, high toxicity refrigerants. This table shows all the possible combinations of flammability classes and toxicity classes. We will go into more detail about the contents of the table after some quick comprehension questions.
Which of the following classes represent refrigerant with highly toxic? Okay. I don't remember. No. B? Yeah. Class B is high toxicity. Which classes represent the refrigerants with low toxicity? This A? Yeah. Which of the following classes represent refrigerant with low flammability? 1. 2. Which of the following classes represent refrigerants that are not
ASHRAE
flammable
recently
at all?
added a new
1.
subclass, 2L, for flammability between Class 2, low flammability, and Class 1, non-flammables. Class 2L refrigerants have low flammability and a slow burn rate. The slow burn rate is what distinguishes Class 2L from Class 2.
What does the new subclass 2L describe? Alternative high flammable refrigerants that are class 2 and burn slowly, refrigerants that are class 2 and take longer to be effective. Yeah, it's about flammability. Oh, refrigerants that are class 2 burn slowly. Okay.
A1 refrigerants are the safest to use.
Yeah.
We can see from this chart that A1 refrigerants are non-flammable and have low toxicity. This makes sense, since Class A refers to low toxicity and Class 1 refers to non-flammable refrigerants. B3 refrigerants are the most dangerous to use. These refrigerants are highly flammable and have high toxicity. This makes sense, since Class B refers to high toxicity and Class 3 refers to high flammability.
Which is the safety classification of refrigerant is most safe? A1 is most safe. Which safety classification is most dangerous? P3. P2 refrigerants are more dangerous than which of the following? P1 and P3. Okay, P3 for sure. And P2. Incorrect. P2 is high toxicity. P2 refrigerant have high toxicity class B. Okay, and the flammability class 2. Okay. Since they have low flammability, they are also more dangerous than P1, which are not flammable. Ah, yeah, this is more dangerous than. I make it opposite. P2 refrigerants are safer than which of the following? Safer than P3 for sure. Safer than A2. B2, B3.
Examples of
Only
A3
B3.
refrigerants
Yeah.
include R290 propane, R600A isobutane, and R441A hydrocarbon blend. Notice that these are all hydrocarbons. Hydrocarbons generally have low toxicity because they are more natural but are also highly flammable. Since hydrocarbons are highly flammable, we need to take extra caution with them. We will discuss specific procedures for this in the safety module. A2L refrigerants include HFO refrigerants like R1234YF. HFO refrigerants generally fall in the category of A2L refrigerants because they contain fluorine. Fluorine makes HFO refrigerants less flammable than hydrocarbon refrigerants, which are highly flammable. B2 refrigerants include R717 or ammonia. Ammonia is a natural refrigerant, as we previously discussed, but it has high toxicity, so it's not ideal for every type of application. Examples of A1 refrigerants include R11, CFC, R22, HCFC, and R410A, HFC. This is why R11 and R22 were popular as refrigerants in the past. They are A1 refrigerants, which are the safest to use. R410A is a blend of two HFC refrigerants that was developed to replace the use of R22 and HCFC. We will discuss more about refrigerant blends in the next module. R410A is also classified as an A1 refrigerant, meaning it is among the safest to use. While it is non-toxic and non-flammable, it can cause asphyxia. This is the most important safety issue when it comes to R410A.
Which of the following statement describe hydrocarbon? They have high toxicity. Okay, they are safe. No, not natural. No, they are high toxic. I don't remember. Okay, they have low volume. No. Yeah, I think. Are A3 refrigerant. Ammonia is safe use because it's natural refrigerant. False. Which safety classification do HFO refrigerant belong? HF2, I don't remember. I think A2L. Yeah. R410 is A1 refrigerant. It is not non-flammable and has low toxicity, making it one of the safest. No. Yeah. Okay, one of the safest R410. Okay. What are the main safety concerns with R410? None. It is an A1 refrigerant, so there are no safety concern. Yeah. Okay. Yeah. Toxicity. Incorrect. Even is non-toxic. It has low flammability. It can still cause asphyxia. This means concern about so it's concerned because we
The
have
ASHRAE classification system provides a general
asphyxia
understanding of how safe a refrigerant
problem.
is. It also helps us understand why a refrigerant might be dangerous to use. This allows us to think of precautions to take with specific refrigerants, based on the dangers present. For example, with a Class B refrigerant, we know to take precautions for its high toxicity. Similarly, with a Class 3 refrigerant, we know to take precautions for its high flammability. We will discuss specific handling procedures in the General Safety module. In this module, we discussed how the ASHRAE organization classified different refrigerants based on their flammability and toxicity.
Okay, so we finish here in refrigerants, the introduction to refrigerants and CFCs and HCFCs. HFCs and HFO and natural refrigerant naming and ozone depletion potential ODP and global warming potential GWP and Asher safety classification. Let's take the quiz for refrigerants. Okay, let's try it. Okay, oh my gosh, this is 59 question. Okay, B2 refrigerant are more dangerous than which of the following? Select to apply. B2 more dangerous than A1 and A2 and also B1. B2 refrigerant are safer than which of the following? Safer than B3. What does CFC stand for? It's chloride, fluorocarbon. Which of the following element do CFC contain? It's carbon, fluorine, and chlorine. What does HCFC stand for? Hydrochlorofluorocarbon. Other than fluorine and chlorine, what do HCFC contain? HCFC other than fluorine and chlorine is hydrogen and carbon. Which of the following modules can be found in HCFC? Select apply. Fluorine, chlorine. Yeah. What does HFC stand for? Hydrofluorocarbon. Which of the following module can be found in HFC? Okay. Helium, hydrogen. Okay. Other than hydrogen, which of the following module the HFC contain? Fluorine and carbon. Okay. What safety classification do HFO refrigerant typically fall under? HFO, I don't remember this one. HFO, I think HFA2L, I think. What does HFO stand for? Hydrofluorocarbon. What does the following is? HFO contain hydrogen. Okay. Which of the following do HFO contain? Select fluoro, oxygen, fluoro, oxygen, carbon. Which statement true about hydrocarbon? Are generally A3 refrigerants that have, yeah. If a refrigerant has ODB of 0.05, which of the following is true? ODB, it contains chloride, chlorine, might contain chloride, it contains chloride. It could be 4R22. Which of the following refrigerant has the highest global warming potential? R12. Which of the following refrigerant has the lowest global refrigerant? Okay, this R1, 2, 3, 4, 5. R11 is the same as CFC 11. Okay. HFC. I don't remember this one. R12 has a GW in which of the following range? This is very high. This is from 10 to 50. R12 is the same as CFC 12. R123 is the same as HCFC. I don't remember this one also. R134 is the same as HFC 134. I don't remember this one also. R410 has a GW in which range? R410 from 1000 to 10. R410 is same like but this one. HFC or HFO, I don't remember. I think HFO. R410 is the same as CFC HFC 410A. The GWB of R290 is greater than which of the following? GWB of R290 greater than which of the following? 290 is greater than R133. I don't remember this one. What is the main safety concern with R400? Let's fix it. What does the new subclass 2L describe? It describes alternative high flame refrigerant that are class 2 and burn slowly. Refrigerants that are class 2 and take longer to be effective. Refrigeration that are toxic. I think this one. Okay. What is the highest possible ODB for CFC, HCFC, HFC, or HFO refrigerant? The highest CFC ODB is 1, I think. What is the least possible ODB? 0. What is the ODB for R44A? 0. What is the ODB? I don't remember this one. ODB for R600, 0 also? I don't remember. Which of the following classes refer to a refrigerant that had a low flammability? Low flammability. What is A? Which refer to that is not flammable? 1. If it is a refrigerant that has a low flammability, it's not flammable. A? I don't remember. Maybe there is one wrong. Which of the following classes refer to refrigerants at high toxicity? B? No. B? Not flame at all. I think this one. And I see low flammability. I think 1 also. I don't know. Which of the following classes refer to refrigerants this will low toxicity? A1. A. Which of the gas is used to reference for meaning GWB? as a reference. Carbon dioxide. Which of the following are CFCs? R12 and R11, I think. Which of the following are HCFCs? Okay, that are seen in the most refrigerant system today. R22. Which of the following are HCFC? Choose to apply. R22. I don't remember this one. And R123, I think. Which of the following refrigerant are HFC? Select all, apply. HFC R143 and R32. Why are HCFC still considered harmful to the environment? Because they deplete the ozone layer, because they cause cancer, because they increase global warming, because they are harmful to plants. I think. Don't remember this one. Which of the following are HFO? HFO, this one. Which of the following statement above carbon dioxide is true? About carbon dioxide. Carbon dioxide has a GW of 1. Has a GW of dioxide has a GW of 0. And has ODB of 1. Which of the following are natural refrigerant? R600A and HC and this R134, I think. Which of the following are not natural refrigerant? R707, 717, okay, 290, 717. Which of the following refrigerant have an ODB greater than 0? Okay, this R22 and R12, I think. Which safety classification of refrigerant which safety classification of refrigerants is most dangerous to use? Safety classification of refrigerant is most dangerous. P3, I think. Which safety classification of refrigerant is most safe? A1. Which type of refrigerant are most harmful to ozone? CFCs. Which types of refrigerants that are least? Okay, need us to log in. Which type of refrigerant are least harmful to ozone layer? Select the all, apply. Least harmful to ozone. HFO and HFC, CFC, HFO only, I think. This least, this high, HCFs, yeah, HFO. Which type of the refrigerant have the lowest GW? Okay, HFO and HCS. Ammonia is safe to use because it's natural refrigerant. No. GWP is a measure of how much energy gas traps in the atmosphere over than 100 years. Yeah, true. If a gas has a GW of 50, that means has a 50 times less global warming than carbon. More, not less. R410 is an AI refrigerant. It is non-toxic and low flammability, making it one of the refrigerant safest refrigeration to use. Yeah, so GWP of HFO and HCS are close to this to HCFC. No. The lowest number for an ozone depletion potential DBO is 1. False. 0. Let's check. This is very long one. Let's see if we have something wrong. We can check it again. Oh, our score is 8.33 out of 10. Oh, this is very good. Let's see the wrong. Oh, 1, 2, 3, 4, 5, 6, 7, 8. Let's check. For 12. Okay, how does FeO stand for? It is hydrofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluorofluor and 19. R11, your answer is R11 is a CFC. Okay. Okay, 22. R123 is the same as HFO 123. Okay. And this one R410 are the same as HFC. Okay. GWP of R290 is greater than which is the following is greater than none of these refrigerant. Oh, none of these refrigerant. And what is this? I mark it. Here because it's partially correct. This, which of the following are HCFC? It's R222 and R123 and R124 also. Okay. 45. Which of the following statement about carbon dioxide is true? The carbon dioxide has GWP of 1. Okay, GWP of 1 and the carbon dioxide of 0. I make it opposite. Okay, which of the following HCFC? This is partially correct also. And one, yeah, I answered this one. This one, which of the following is not natural refrigerant? It is R130. It's not a natural refrigerant. Okay. This one is partially okay, correct. HCFs and HFO and none. Yeah, this means HFO and HFCS. Okay. This 155 GWP is measure how much energy gas traps in the atmosphere over 100 years. Method of flow. The GWP is measure of how much energy of gas traps in the atmosphere over 100 years compared to carbon monoxide. GWP is not measure of the amount of energy. Okay. Is measure of how much energy of gas trap in the atmosphere of over 100 years compared to carbon dioxide. It must be compared to carbon dioxide. Okay, that's all. But we solved it correctly. Okay. So in this core we finish refrigerant, introduction to refrigerants and CFCs, HCFCs, HFCs, HFO and natural refrigerant naming, ozone depletion potential, global warming potential and actual safety classification, and we finish the quiz.